In the previous video, I introduced the concept of a logarithmic function. And the logarithmic function with base b is written f of x equals log base b of x, where y equals f of x. And it means that x equals b to the y power. Its domain is 0 to infinity, and that's because it is the inverse of the exponential function, which has range all positive real numbers. So when you have inverse functions, the domain and range switch, just like the x and y. Its range is all real numbers, just like the domain for the exponential function is all real numbers. And of course, b must be greater than 0, and b is not equal to 1. It's important to note that x equals by is an equation that describes the logarithmic function having base b, and this is the exponential form of the logarithmic function. If b equals 10, then we write it without a base. It's called the common logarithm. And if b equals e, which is the number we talked about in the last section, then f of x is denoted ln of x, and this is called the natural log. So we have the common log with base 10 and the natural log. And you will recall that logarithmic functions have exponential form and logarithmic form, and we need to be able to go back and forth between the two forms. They mean the same thing, so we're going to do some examples of how to go back and forth between the two. We have, first we're going to talk about changing from logarithmic to exponential form. You'll see all of these equations have logs in them. So that means that they are logarithmic, in logarithmic form. And now we're going to write them in exponential. And the way we do this is we say the log is the exponent. So here's the log. Equal in math means is. And here is the exponent. The log is the exponent. So the base is always on the bottom. So we put the base and then we raise it to the power, which is the exponent right here. And then the number that's left is what that expression is equal to. All right, let's try this one here. Here's the base because it's on the bottom. So the base is 9. I can write that down. The log is the exponent. So I put the 2 in the exponent. And the number left, in this case it's a variable, is written. Now here, the b is on the bottom, so that's the base. The log is the exponent, so the 3 is the exponent, and 27 is left. Here we have the bottom is 5, that's the base. So I write that. The log, that's this expression, is the exponent. So y is the exponent, and what's left is the 125. So it's equal to 125. All right, so that's changing from logs to exponential form. Now changing from exponential form to logarithmic form. Remember that the base is on the bottom and the log is the exponent. So we say the log, and the base is on the bottom. That's the base. It's under the exponent. Here's our number. And we say the log is the exponent. That's 4. Okay? The log is the exponent. The base is on the bottom. That's the 15. And x is what's left there. Okay? The base is on the bottom, so it's going to be log base 2, and the log is the exponent. So the exponent goes right here. Well, that's just -4. See how -4 is in the exponent? So we write it here. The log is the exponent. And finally, this number goes in that space that's missing there. All right, here. We have to, before we can do this conversion, we need to write this as an exponent. So this is equivalent to 64 to the 1/3 power. That's what cube root means. It means you raise it to the 1/3 power. And now we can proceed. We have the log is the exponent. So the base is on the bottom. This is the bottom number under the exponent. So I can put 64 down here. The log is the exponent. That's the 1/3. And the 4 is left over, so it goes in that slot. Here we have the bases on the bottom. So log base b is, the log is the exponent. The exponent is 3, and this number is left. Finally, the base is on the bottom, and the log is the exponent. So that's y, and 300 is left over. That goes in there.